Welcome to Intermolecular Forces, Solids and Liquids. My name is Dr. English. Today we're going to be talking about two terms, system and surroundings. So we're going to start by talking about what is thermochemistry, and then we're going to relate that concept of thermochemistry to system versus surroundings. Then we're going to talk about endothermic processes, exothermic processes, and then do a practice problem at the end. What is thermochemistry? Thermochemistry is the study of the relationship between chemistry and energy and how that energy is exchanged over time. In order to understand energy exchange in chemistry, two terms need to be defined. The first is the system and the second is the surrounding. So what do we mean by the system? The system is a very specific concept that is being studied. Depending on the situation, a system could be defined as a chemical reaction or a physical change that occurs. The surrounding, on the other hand, is everything with which the system can exchange energy. This is the remainder of the universe outside of the defined system. Defining the system and the surroundings allows a better understanding of the law of conservation of energy. This law states that energy cannot be created nor destroyed. Energy can be transferred between the system and the surroundings. The terms endothermic and exothermic are used to describe this exchange. Endothermic processes. Chemical reaction or physical change in which heat is absorbed, that's really key, absorbed from the surroundings into the system. Let's look at two examples. We can have an endothermic chemical change. So diatomic nitrogen reacts with diatomic oxygen, absorbs a certain amount of energy, and produces 2 moles of nitrogen monoxide. So this is a chemical system in which we have two reactants absorbing energy to come together to form a new product. We can also have an endothermic physical change. In this situation, solid water, known as ice, absorbs a certain amount of energy, in this case 334 joules per every 1 gram of ice, to form liquid water. As a result, the temperature of the surroundings will decrease as energy is absorbed into the system. Now let's look at an exothermic process. This can be a chemical reaction or physical change in which heat is released from the system into the surroundings. So an example of an exothermic chemical change could be aluminum reacting with oxygen to form aluminum oxide and an amount of energy. In this case, 3,351 kilojoules per every 2 moles of aluminum oxide. An exothermic physical change could be liquid water releasing 334 joules per every 1 gram of liquid water to form ice. This is an example of a physical change that is exothermic. As a result, the temperature of the surroundings will increase, which we could measure with a thermometer, as energy is released from the system. Let's look at a practice problem. When ammonium nitrate is dissolved in water, the temperature of the water decreases. When sodium hydroxide is dissolved in a separate water sample, the temperature of the water increases. Based on these observations, it can be concluded that the dissolving of both salts are endothermic, both salts are exothermic, ammonium nitrate is endothermic, and the dissolving of sodium hydroxide is exothermic, or ammonium nitrate is exothermic and the dissolving of sodium hydroxide is endothermic. There's a lot going on in this problem, so let's break it down. In the first part of the problem, it states when ammonium nitrate is dissolved in water, the temperature of the water decreases. The temperature of the water is going down. So the system here is the ammonium nitrate dissolving in water to form ammonium ions and nitrate ions. This act of forming these ions is the system, and in order to do this, it needs to absorb a certain amount of energy from the surroundings. Therefore, this would be considered endothermic. When sodium hydroxide is dissolved in a separate water sample, the temperature of the water increases. In this case, it's increasing. The system is the sodium hydroxide forming sodium ions and hydroxide ions. And when this process happens, when these ions are formed, energy is released from the system into the surroundings. And again, we can measure that using a thermometer. So because the temperature of the water, which is our surroundings, increases, this process is exothermic. So let's go back and look at our possible answers. So if you were to pick one, hopefully you picked number 3, where ammonium nitrate is endothermic. And again, we can see that it's endothermic because the temperature of the water decreases, and the dissolving of sodium hydroxide is exothermic, which means the temperature of the water increases. So the correct answer in this case would be number 3. So what did you learn? We talked a little bit about what is thermochemistry, but it was very, very brief. We differentiated between system versus surroundings. We talked about endothermic processes, exothermic processes, and then we looked at a practice problem at the end. Need more help? Feel free to contact me. Have a great day.